about measures of dispersion. So why we use measures of dispersion? The averages or the measure of central tendency gives central point around which the data is concentrated or around which data is scattered. But the measure of central tendency alone is not good enough to describe the data completely. For example, two sleep producing drugs were administered for two groups of patients and their sleeping times are recorded, which are given below for drug A and for drug B. But when mean is computed, the arithmetic mean for both the drugs is 3.7 hours. So there is a question that which drug should be preferred and why. So drug A would be preferred as observations are much closer to the mean as compared to drug B. Here you can see that for drug A, the measures are 6, 2, 4, 5, 3, 2, 1 that are much closer as compared to drug B, where three observations are 6 or 7 and three observations are 1 and 2. So we can say that drug A is more consistent or more concentrated around its mean. So drug A should be preferred. So this concentration should be measured by using some values. These measures of concentration are also called as measure of dispersion. The measure of dispersion are used to define the concentration or spreadness of the data, as well as these are also helpful in comparing the two different data sets. The main measures of dispersions can be classified into two groups. One is called as absolute measure of dispersion and other is called as relative measure of dispersion. Both are used to measure the concentration of the data as well as to compare the two different series of data. But measures absolute measure of differences, absolute measure of dispersions are used when the mean of two or more series or two or more data sets are same or the unit of measurements are also same. Whereas relative measure of dispersions are used when the mean of observations are not same or the unit of measurements for two or more groups are different. The main measures of absolute measures of dispersion are range, quartile deviation, mean deviation, and standard deviation. And main measures of mm, main relative measures of dispersion are coefficient of range, coefficient of mean deviation, coefficient of variation, and coefficient of quartile deviation. So first we will go for absolute measure of dispersion. First one is range. The range is nothing but the difference of highest and lowest observation, or you can say maximum of the observation and minimum of all the observation. It is the simplest measure of dispersion, but it has a drawback that it considers only two observations, that is maximum and minimum, whereas it does not take consideration of all other values. So it is least preferable measure of dispersion. How it is calculated? For example, we can consider the five observations 4, 6, 9, 3, and 7. Among these, we can see that minimum observation is 3 and maximum observation is 9. So range will be 9 minus 3, that will give 6. So range of data is 6 units. Second measure of second absolute measure of dispersion is mean deviation. It gives an improvement over range that it consider all the observations. It is given by the average of absolute deviation of observation from measure of central tendency. That measure of central tendency may be mean, may be median, may be mode, may be harmonic mean, may be geometric mean, or any other measure of central tendency. The formula for Computing the mean deviation is given by, for raw data, mean deviation about origin A is 1 upon n summation I goes 1 to n xi minus A, where A is a measure of central tendency, or you can say any assumed mean. And for frequency data, that is for class interval data or for discrete data, we can calculate mean deviation using the formula 1 upon total frequency into summation I goes 1 to k fi x mod of xi minus A, and total frequency is summation fi. This mod represents the positive value of difference. That means if xi is 3, then mod xi will be 3, and if xi is minus 3, then also mod of xi will be 3. That is whether it takes positive value or it takes negative value. If we put mod, then it will give positive value. So we can say the average of positive difference of observation from respective measure of central tendency. And if in place of A we consider arithmetic mean or simply mean of the observations, then it is called as mean deviation about mean, or you can also call it as mean deviation. And formula would become mean deviation equals to 1 upon n summation I goes 1 to n xi minus x bar for raw data, and 1 upon capital N summation I goes 1 to k fi xi mod of xi minus x bar, and 1 upon summation fi is 1 upon total frequency, or you can say 1 upon capital N. The mean deviation also have same merits which the mean have, and it also suffers all the demerits of arithmetic mean. That is, it cannot be calculated for open-ended class intervals. It cannot be calculated for qualitative data. It cannot be calculated if at least one of the observation is missing, and so on. But it has one more drawback which restrict its use, that it ignores the sign of deviation. That is, x, if xi minus x bar is positive, then deviation will be positive, and if xi minus x bar is negative, then it is also converted it into the positive. That means it ignores whether the deviation is positive or deviation is negative. So it restricts the use of mean deviation. To overcome this difficulty, another measure is defined which is called as standard deviation. Standard deviation can also be called as the square root of squared deviation of observation from respective means. Standard deviation is given by square root of 1 upon n summation I goes xi minus x bar whole square. That is square root, that means square root of average, that is 1 upon n summation I goes 1 to n of deviation of observation, of square of deviation of observation, that is xi minus x bar whole square from respectively. For frequency data, the formula will become summation, sorry, sigma is equals to square root 1 upon capital N summation I goes 1 to small n fi xi minus x bar whole square, where capital N is total frequency and here small n represents the number of class interval or number of groups. There are some other formulas, sorry, and there is another thing which is called as variance, which is nothing but the square of standard deviation. The properties of standard deviation can be mentioned in terms of variance much easier as compared to in terms of standard deviation. The variance is used to measure the average square distance of observation from their respective arithmetic mean. For raw data, variance of x is given by sigma square is equals to 1 upon n summation I goes 1 to n xi minus x bar is whole square. And for frequency data, it is given by sigma square is equals to 1 upon capital N summation I goes 1 to k fi xi minus x bar whole square. For making the computation easier, this formula can be expanded as 1 upon n summation I goes 1 to k fi xi square minus 1 upon n summation I goes 1 to k fi xi whole square. You can say 1 upon n summation I goes 1 to k fi xi square minus x bar square. Similarly, for raw data, it can also be expanded. So there is another method for calculating the variance, which is similar to the computation of mean using step deviation method. So in step deviation method, the calculation become much easier as compared to formula given for the variances. Here the formula will become variance of x is equals to 1 upon n summation I goes 1 to k fi di square minus 1 upon n summation I goes 1 to k fi di whole square multiplied with h square, where di is the deviation of observation from assumed mean, that is di is equals to xi minus a. H is width of class interval, a is assumed mean, and capital N is total frequency, and Fi is frequency of ith group. Now properties of variances. Let x1, x2, xn and y1, y2, yn denotes two sets of observations with variance Vx and Vy respectively, and A and B be any constant, then variance of Ax is equals to A square variance of x. That means if we multiply all the observations by a constant, then variance should be multiplied by square of the constant. And second property, variance of x plus b is equals to variance of x. That means if we add same quantity or same constant to all the observations, then it would not affect the observations. Sorry, it would not affect the variance of observations. So both the properties 1 and 2 can be clubbed into a single property, that is variance of ax plus b is equals to a square variance of x. And it also shows that the variance of observations is independent from change of origin but depend upon the change of scale. Change of origin, that means any quantity can be added into the observation or subtracted from all the observations, then variance will not affected. That is independent of change of origin. But if we multiply or divide observation by some constant, then variance would be changed. That is, it is not independent of change of scale. Fourth property said that variance of x plus y. That means if we add these two series, then the variance would become variance of x plus y is equals to variance of x plus variance of y plus variance 2 times covariance of xy. This 2 COV xy is called as covariance of xy. Similarly, in place of adding, if we subtract the respective observations, then variance of x minus y would become variance of x plus variance of y minus 2 times covariance of xy. And covariance of xy is given by the formula COV x comma y is equals to 1 upon n summation I goes 1 to n xi minus x bar into yi minus y bar. However, covariance will be discussed later with the correlation in detail. And if x1, x1, x11, x12, x1n1 be one set of observation having n1 observations and mean x1 bar and variance sigma 1 square, and x21, x22, so on, x2 and 2 be another set of n2 observation with mean x2 bar and variance sigma 2 square, then if two series are combined in one, that is we have get n1 plus n2 observations, then the mean of combined series would be sigma square is equals to 1 upon n1 plus n2, n1 sigma 1 square plus n2 sigma 2 square plus n1 n2 upon n1 plus n2 into x1 bar minus x2 bar whole square. That means if we have two series and their number of observations, mean and variances are known to us, then easily we can calculate the mean variance of combined series. And also the standard deviation, we were discussed about the standard deviation, then properties of standard deviation are discussed in terms of variances. So the variances and standard deviation as both involves the arithmetic mean. So both suffers from all the drawbacks of arithmetic mean and having all the properties of, sorry, and all the merits of arithmetic mean. However, it is suffers from a lot of demerits, like it cannot be calculated for open-ended class interval. It cannot be calculated if at least one observations are missing, and too many demerits. It is most frequently used measure of dispersion among all absolute measure of dispersions, as it is based upon all the observations, and it is more suitable to algebraic and statistical computation as compared to other measures. Other measures are not suitable for mathematical or statistical computation. And standard deviation has also a drawback that it cannot be calculated for qualitative data. So for qualitative data, another measure of dispersion is defined, which is called as quartile deviation. It can also be called as semi-interquartile range. A semi means half, interquartile range means the difference between maximum and minimum quartile. So maximum quartile is called as third quartile, which is denoted by Q3, and minimum quartile is also called as first quartile, which is denoted by Q1. So interquartile range will become Q3 minus Q1, and semi-interquartile range will become half of Q3 minus Q1. So quartile deviation will be called as half of Q3 minus Q1. It also provides a better measure of scatteredness in case of rank order data. That means for qualitative data as well as for ranking data. However, it has also a drawback from which the range also suffers, that it ignores all the other observations and it is based upon only two observations. Therefore, it is less preferable as compared to standard deviation in case of continuous data. However, for qualitative data, quartile deviation is preferable. Now, when we can calculate absolute measure of dispersion, why we go for relative measure of dispersion? That can be explained with the help of following example, where I have considered the salary of 5 workers in two different companies. These salaries are measured in terms of rupees, or you can say in terms of dollar. That is, unit of measurement for both the companies are same. So we consider case 1. Here you can see that average of both the average salary for both the companies are same. That is 17 units. But variances varies. For company C1, the variance is 14, and for company C2, variance is 167. So which company should be preferred? The company C1 should be preferred, as there are less chances to get a smaller salary as compared to C2. If you join company C1, then minimum salary will be 12 units and maximum will be 22 units. Whereas if you join company C2, then minimum salary will be 2 units only. So it will be better to prefer C1. In case 2, Here you can see variances for both the companies are same, that is 14 units, but their average salary are differ. That is for C1 average salary is 17, for C2 average salary is 20. So one will prefer to join company C2 as average income is higher as compared to C1. Now we come to case 3. Here we can see that the average income or average salary differs, as well as as well as variances are also different. So in that situation, which company should we prefer? Either C1 or C2. That cannot be decided easily. So we can decide that which company in case 3, that is C1 or C2, should be preferred with the help of relative measure of dispersion. That means we represent both in same units, or we can say that is we change their mean, or that is how that can be obtained, that will be discussed. There are four measures of relative dispersion or relative measures of dispersion that are called as coefficient of range, coefficient of mean deviation, coefficient of variation, and coefficient of quartile deviation. The process, these are relative measures of dispersion, and the main purpose of these relative measures are make the dispersion unitless. So the quantity which is used for the computation of absolute measure of relative dispersion, from that the measure of dispersions are divided and made unitless. For example, coefficient of range, for calculating range we use maximum and minimum observation. Range is maximum of observation minus minimum of observation, and coefficient of range would become maximum observation minus minimum observation divided by maximum observation plus minimum observation, and it is multiplied with 100 to represent it in terms of percentages. Similarly, for coefficient of mean deviation, we can divide mean deviation above by the origin about which it is calculated. That is, coefficient of mean deviation is MD upon A into 100. If we use simple mean deviation about mean, then it formula will become mean deviation upon X bar into 100. Third one is coefficient of variation. Coefficient of variation is based upon standard deviation, and standard deviation used mean, arithmetic mean of the observation. So for coefficient of variation, the formula will become standard deviation divided by arithmetic mean into 100. That is sigma upon x bar into 100. Similarly, for quartile deviation, we can obtain coefficient of quartile deviation. Quartile deviation uses two quantities, first quartile and third quartile. In same manner, we use in the range, same for steps are used in the quartile deviation. That is Q3 minus Q1 divided by Q3 plus Q1. Now, how we calculate these measures of dispersion, that is range and quartile deviation and so on. So here it is an example that compute the measure of dispersion for following set of observations. It is given these observations. I think these are 10 observations. So for first we compute the range. For range we find maximum and minimum observation. So minimum observation is 70 and maximum observation is 108. So range will become 108 minus 70, that is 38. And coefficient of range will become 38 divided by 108 plus 70, that is 138 upon 178. That is will give 0.2135, and it will be multiplied by 100, so it will become 21.35%. For mean deviation, first the computation of mean is necessary, as well as for standard deviation. So first we compute mean, that add all the observation and divide by its count. So the number, it will give 880 divided by 10, that is average is 88. Now we calculate observation deviation of observation from their mean, and then its absolute value, and for standard deviation we square these deviation. So third column represent absolute deviation, whereas fourth column represent square deviation. And then add these absolute deviation and square deviation, then we will obtain total absolute deviation is 94. So mean deviation will be 94 divided by number of observation, that is 10. So mean deviation is 9.4, and coefficient of mean deviation will become 9.4 divided by its mean, that is 88, which will give 10.681. Similarly, squared, the sum of square deviation is 1216. It will be divided by number of observation and take square root, it will give 11.03, and coefficient of variation will become 12.53. In next fourth measure, that is quartile deviation, first we calculate first quartile and third quartile, and it is discussed in measure of central tendency. So first quartile is comes out to be 78, third quartile comes out to be 95.5, and quartile deviation will become 95.5 minus 78 divided by 2, that comes out to be 8.75. Similarly, coefficient of quartile deviation will become 8.75 divided by 95.5 plus 78, which will give 10.09. Similarly, we can calculate measure of dispersion for frequency data. For frequency data, first we calculate mean, that is first we calculate the mid value of class interval xi. Then we can use step deviation method, or we can directly calculate mean by using fixi. Then it will give the mean as 209.07. Then deviation of observations from mean, that is xi minus 209.7 and its mod. Then calculate mean deviation using the formula. For standard deviation, we can directly square this absolute deviation, that is xi minus mean ka whole square, or we can use step deviation method, where we use change of origin and scale. I have using step deviation method, where assumed mean is taken as 205 and width of class interval is 10. So di will be obtained xi minus 205 divided by 10. So here di will become minus 3 minus 2 minus 1 0 1 2 3 4. Its square and multiplication with xi will become much with fi will become much easier. That is 52 into minus 3, which will give minus 156, and so on. And putting into the formula, we will get standard deviation as 19.764. Now one more important thing, which is box plot. Box plot uses three quartiles as well as interquartile range. How box plot is constructed? On box, for construction of box plot, we have two axes. On vertical axis, we take the observations. That is divided the axis in terms of observations. Then we draw a line which represents first quartile, another line which represents median, third line which represent third quartile. By combining these three lines, we construct a box like this. And from the upper end and lower end of these boxes, from mid, we draw two lines of height 1.5 interquartile range. That is 1.5 into Q3 minus Q1. So in this manner, box plot is constructed. These two lines, which are of height 1.5 IQR or interquartile range, are called as whiskers. Any observation above these two whiskers are called as outliers. And if these observations are above the 3 times of interquartile range, that is 1.5 this, and above 1.5 interquartile range, this, that are called as extreme values. Outliers are permitted 1 out of 100, whereas extreme values are permitted 1 out of 1000 in the data set. That is, if we consider the data of 1000, then there should be only one extreme value. Otherwise, calculation may mislead. So it is all about the today's lecture. These are the references.